In this tutorial, we will be discussing the difference between solids, liquids, and gases. Solids have a very rigid shape and a fixed volume. The external shape can reflect the atomic or molecular arrangement. We know these pretty well. Liquids, however, have no fixed shape and may not fill the entire container completely. Instead, it just sits at the bottom. We really don't know as much as we'd like to about the liquids. And gases fill the entire container. We have a pretty good theoretical understanding of these. So when we go from solid, liquid, and gases, we can do so by changing the temperature. We go from solid to liquid by heating it up, and for liquid to solid by taking the heat away by cooling it down. We can do the same thing to go from a liquid to a gas. However, in addition to using the heat, we could also look at the pressure. Solids and liquids are fairly compressed as it is. Notice that the liquids are a little bit more spread out on typical. Now, water is an exception to this rule. But typically, the molecules are a little bit more spread out in a liquid than they are a solid, with, once again, an exception of water. Now, if you look at that in comparison to gases, there's a lot of difference in the distance between the molecules. Because of that, we can actually change the pressure of the gases far more easily than we could change the pressure of a liquid or a solid. And so by changing the pressure, we could actually change it from a liquid to a gas. For instance, if you reduce the pressure, in other words, spread it out more, you can go from a liquid to a gas. If you compress it and increase the pressure, you can actually change it back to a liquid. Let's take a look of a comparison between water molecules, or H2O, from a gas, a liquid, and a solid. Let's start with the molecular view on the right-hand side. Notice the molecules are much more spread out when it's a gas, whereas with the liquid in the solid form, they're much more condensed. Also take a look at the difference between a liquid and a solid. The solid is very systematic. It's showing a picture where the molecules are very directly arranged, whereas the liquids are far more random. Because of this very compact arrangement and very distinct arrangement, it actually ends up spreading out rather than getting closer together. This is evident when we look at the densities. The density is actually smaller for solid than it is for liquid. We can see this in everyday life by the fact that ice floats when we have ice water, or ice in a soda or whatever. Ice will always be on the top and the liquid will be on the bottom. That's because the solid is less dense. We can also look at this in comparison with the molar volume. This is the amount of volume it takes to hold 1 mole, which you may remember is 6.02 times 10 to the 23rd molecules. So to hold that many molecules of a gas, you would need 30.5 liters of a gas. Whereas for a liquid, you would only need 18 milliliters. Notice the difference between milliliters and liters. So you need far less volume to hold the same amount of molecules. Now look at the gas. You actually need, or solid, pardon, the solid. You would actually need more volume, just slightly more, but still more, to hold the exact same amount of molecules. So once again, it spreads out when it's a solid. And this is a phase diagram for water, specifically water. In a phase diagram, every single compound has its own phase diagram, and you'll see several similarities. For one, they always have the physical states, solid, liquid, and gas. They have 3 lines here that divide them. For instance, this is the sublimation curve. It goes from a solid to a gas and back again. So at a specific pressure, once it hits a specific temperature, it's going to turn from a solid to a gas. Same with the liquid. Here's the fusion curve. Once you're at a specific pressure, you hit a specific volume, a specific temperature, and it's going to turn from a solid to a liquid, and vaporization as well. In the middle, you have what's called the triple point, which is where all three phases of matter exist in equilibrium. And on the upper right hand corner, you have the critical point, which is the highest temperature and pressure liquid phase can exist no matter how high the pressure. And that gives you an overview of the three states of matter.